In this video, we're going to be talking about charging and discharging a capacitor still. Okay, now here's the problem on the board. It says a 600 microfarad capacitor discharges through a 100 kilo ohm resistor. Remember I said in my previous video under discharging and discharging of the capacitor that you need the resistor to charge or discharge it. Okay, now calculate the time it takes the charge on the plate to decay by 2/5. Now, I want you to answer this question. You might want to pause the video after I've asked the question. Think about it, then play the video to see if your answer is correct. What do you think would be the necessary equation to solve this problem? Is it Q is equal to Q naught in brackets 1 minus exponential minus T over CR? Okay, you think it will be this equation, Q equals Q naught in brackets 1 minus exponential minus T over CR? You think this will be it? Or we're going to make use of Q is equal to Q naught exponential minus T over CR. What do you think will be the right equation? Now, assume that you've paused the video. Now, I'm going to tell you the answer. The right answer is going to be this. Why? Because in my previous video, I also talked about charging and discharging a capacitor and the right equation to use depending on the problem given. So in this case, they talked about discharging of a capacitor. You can see the word discharge. So it means what now? We are making use of the capacitor. What we are going to make use of is this equation, okay? This equation over here. Now, the question was also kind of tactical, okay? It said, after it was discharged through this amount of resistor, we want to calculate the time it takes the charge on the plate to decay by. Now, there is a difference when you are told that it is decayed by and it is decayed to. If it is decayed to, it means the value we are now going to have for Q is going to be what now? 2/5 times what now? Q naught, which is the maximum value we are coming from. Okay? But if you are told that it decays by, it means it reduces by 2/5 of Q naught. Now you are being told that it what now? Decays by. So it means in this case, we are going to have the value of Q to be Q naught, which is the initial value, minus 2/5 of this same initial value. Okay, and then this will be equal to Q naught exponential minus T over CR. We are asked to find time, right? Now, you subtract this. When you subtract this, you get 3/5 Q naught, and this is equal to Q naught exponential minus T over CR. Now, Q naught cancels out Q naught. So we are left with taking the lane on both sides. We are going to have lane 3/5 is equal to minus T over CR. We want to make T the subject of the formula. Now, when we make T the subject of the formula, we are going to get T is then equal to minus lane 3/5, okay, divided by, is it divided or multiplied rather? Multiplied by CR. So it means T is then going to equal minus CR lane 3/5. Now you are given the value of C in the question as 600 microfarad and R as 100 kilo ohm. Okay, so then C is going to be equal to minus C is 600 microfarad times 10 to the power of minus 6, okay, times R is 100 kilo ohm. So you have 100 times 10 to the power of 3, okay, then lane of 3/5. Now we'll do this on the calculator, okay. I have minus 600 times 10 to the power of minus 6 times 100 times 10 to the power of 3 times the lane of 3/5. I'm going to get a value of, I'm going to get a value of 30.65 approximately. So T is equal to 30.65 approximately, okay, seconds. So that is how a problem like this is being solved. So the main thing you need to know is these key features, when they take decayed by and when they take decay to. Those are two things. And then again, you also need to note if the question talks about charging or discharging of the capacitor, okay. These are some key features that you need to take note of in solving problems of charging and discharging of a capacitor, okay. So that is all for now, and in our next video we'll be moving on to different aspects of electromagnetism and physics as well, okay. Don't forget to like, share with your friends, and click on the notification bell so that when I upload these more videos you get notified, you don't miss out on any of it. And don't forget to subscribe to the YouTube channel Dr. Flash. See you in the next video.